All right, welcome everyone. I have first a message from our calc tutor, Erin Nitz. It's on the screen. She has announced there's going to be a special study session Thursday from 7 to 9 p.m. She is aware there's going to be a test. And anyway, nice offer by our calc tutor. So keep that in mind for your schedule. So this is our main topic today. We're going to take questions on the 2.5 assignment, and then we're going to begin the review of Chapter 2, try to get as ready as we can for the upcoming test. So let's start off with any questions you may have on the 2.5 assignment. So either unmute and ask, or you can do it in the chat. You can do it in the side chat if you'd like.
How long is the test going to be?
How long? What were you referring to, time-wise?
Like how many questions are going to be on the test?
Oh, boy, I could ask one question that's too long. I could ask 20 that's too short. That's really hard to answer. I mean, obviously, I have attempted to make it about 40 minutes long, so that there's a 10-minute gap between that and the end of the period.
Is there just a little bit of stuff like from each section, kind of? Like a little bit from 2.1, a little bit from 2.2?
That's the idea, but sometimes there's not enough time to include something from every section, but that's the idea. Try to equally distribute it throughout the chapter.
Is there anything that we should like really, really study, like a little bit extra in the next couple of days that's going to be on there?
Well, anything. There's really, you'll see. I'm going to show you some things that you might want to look at that you might pass over when it comes to things before Chapter 2. Technically, this is a Chapter 2 test. But, for example, when you calculate a limit, there's some, you got to add to find your limit. So somebody could say, what, addition? That wasn't in Chapter 2. So I've got a couple topics related to Chapter 1 that you'll see they're going to come up. Here's what I call it on the slide. I say things to look at from before Chapter 2. So, questions on 2.5? Anything you'd like to talk about? I will say this, in the first session this morning at 8 o'clock, which there's a link for on your website, there were a whole bunch of 2.5 questions. So if you want to look at, review some things that came up with that, view that first video. One more time, any 2.5 things that you'd like to see brought up? I'm looking at chat to make sure nobody's trying to get through that way. It doesn't look like it. All right, well, then let's get started. So some advice on things, before Chapter 2. It's a Chapter 2 test, but you can't, as you well know, what has kept coming up in this chapter on limits. Welcome, Sam. Things that have come up in Chapter 2, let's face it, trigonometry keeps coming up, so that's why that one's down there, trig basics. Remember, we learned how to do a difference quotient. You need to know how to do that. Solving quadratics. Maybe another one would be brush up on your factoring techniques, because factoring has a lot to do with when you're determining whether or not there's an asymptote or a hole. Factoring has a lot to do with it. So here's the first. Here's one of those. One of those algebra concepts that may come up. This is just a reminder: when you have the difference of two cubes, you can break it into a binomial and a trinomial. By the way, is this the difference of two cubes? When you look at it, you can probably see that 27 is a cube, 3 times 3 times 3. But some people look at a to the 18th and they say, oh, 18 is not a perfect cube. That's true, it's not. But a to the 18th is, because it's a to the 6th times a to the 6th times a to the 6th.
Can you go over 1 through 3? I'm on 2.5.
Oh, we got a 2-5 question. 1 through 3, all right?
1 and 3.
Okay. There was number 1 a picture in the book? I got to go take a look. Number 1 on 2-5. Taylor, you might want to mute. You're in a. You must be in a pretty active place for sound. Okay, so number 1 is a. So to answer your, yeah, I gotta quiet down this loud crowd here. That is Taylor. Yep. Okay. So now we're back. So anyway, the question was numbers 1 and 3. So let's take a look here. Let me try to make that even bigger. Okay, so number 1, we have this graph. And the question is, as x approaches infinity, so it says determine whether f of x approaches infinity or negative infinity as x approaches -2 from the left. So as x approaches -2 from the left, it's going up forever, so it approaches positive infinity. And as it approaches -2 from the right, do you see how it's still going up? So it approaches, so in both of them, on number 1, it would be positive infinity. Excuse me. So let's take a look at number 3. So we got this graph, tangent pi x over 4. And again, it's -2 we're interested in. As x approaches -2 from the left, it's going forever up again. So that would be positive infinity. As x is approaching -2 from the right, you see how it's heading down forever. So that would be negative infinity. So that's numbers 1 and 3. Somebody requested that. So let's go. Let me open it up once again, since we had some later entries here. Any 2-5 questions?
For number 5, like 5, 9, should we try and like put that into a calculator and graph it? Or do you think that, is there a way to tell if it approaches negative infinity or a positive infinity just by doing the problem?
Yeah, there is. You can't rely on graphing because you can't use a calculator on the test. So let's take a look at number 5. It's down there on the bottom. It says determine whether f of x approaches positive infinity or negative infinity as x approaches 4 from the left first, and then we'll do from the right. So from the left, that would be when it approaches 4 from the left, that would be like what, 3.9? Just a little bit less than 4? And what's 3.9 minus 4? Negative 0.1, right? So it's a negative small number. That's the point. And what's 1 over a negative very tiny number? It's going to be a negative infinity, because first of all, 1 over a tiny number, you know, like what's 1 divided by 1/10? 10. What's 1 divided by 1/100th? 100. So you can see as we get closer to the smaller number, the answer is just ballooning upwards toward infinity. The question, but because it's a small, 3.9 minus 4 is a negative small, it's going to be negative infinity. So it's going to be infinity, but because it's a positive over a negative, it's negative infinity. All right, now turn it around. What happens when we approach 4 from the right? So now from the right, it's going to be like 4.01, just a little bit more than 4. What's 4.01 minus 4? Positive 0.01. So we got a big number divided by we got a number divided by a tiny number. It's going to again get huge, but this time it's positive over a positive. So this time the answer is positive infinity. So that's how I would think through number 5 if it was on the test. I don't know if I got that. Did that make sense? Do you have any follow-up on that? Or
oh, that makes sense. Thanks.
You're welcome. Still open to 2.5 questions. I will repeat, for those of you who just joined, that the 8 o'clock session today, I had a lot of really good 2.5 questions. So if you want to see a whole bunch of them, look at the first video. The link is up on your website.
So 7, since the denominator gets squared every time, and no matter if you get negative or a positive, wouldn't from the left and right be going to positive infinity because none of them are getting divided by a negative small number?
That is exactly correct.
Okay.
So any more 2.5 questions? If not, I'm going to advance over to the review exercises, so we're ready to go there. Okay. Well, so one more. This is a little bit. We're going backwards a little bit, but that's because we had some people arrive late. Okay. So this is our topic, and as I was saying to the class, even though it's a Chapter 2 test, there always are some carryovers. I mean, you can't just completely forget about trigonometry and solving quadratics because, as you know, trig kept coming up in the assignments, right? Even though trigonometry was not the topic, we had a whole bunch of trig questions in Chapter 2. So here are some reminders, things from before. Difference quotient. Remember what a difference quotient is? F of x plus h minus f of x all over h. I should write it out here for you. Well, we're going to show it in just a minute. I've got slides on those. Secondly, solving quadratics. So just a quick refresh, what's the quadratic formula? Do you know how to solve quadratics by factoring? I know you do. Maybe brush up on your factoring techniques. Also, we learned how to solve quadratics by using completing the square. And then trigonometry, as you saw in the chapter assignments, is huge. So here's one of the, we were looking at this, and this is where people came in, so I backtracked. Okay, so don't forget, here's one kind of factoring you might forget, the difference of two cubes. Remember that? Binomial times trinomial. The beginning of the binomial you'd put the cube root of the first term, you put the cube root of the second term, negative 64b to the 6, put that in here. You mimic the sign. And then in the trinomial, you take the 3a to the 6 squared. That's where you get the 9a 12. You square the 4b squared. You put that at the very end, 16b to the 4th. And then in the middle, you multiply these two. 4 times 3 is 12. A to the 6b squared. And the sign here is always the opposite of the sign in that first term. So here's just a reminder, solving by completing the square. So in this quadratic, if we want to solve by completing the square, we would first remove the 90, subtract it, and then we can't have that 2 out in front there. In order to complete the square, we must have a 1 there. So we have to divide everything through by 2. Make that 9/16 is actually not there yet. Just make believe it's not there on both sides. But to determine that, we take half of this x coefficient, 3/2. Half of 3/2 is 3/4 squared, 9/16. So that's what we add to both sides. This trinomial on the left is now a perfect square, so we write it as a binomial squared. Where did I get the 3/4 from? It's always half of that 3/2 coefficient, half of 3/2. Once you've got your square written, then you can take both square roots, which we did down in this step down here. This particular problem, we aren't going to get an answer real because we have the square root of a negative, but nevertheless, the technique is good. You've got to take both square roots, and then you subtract the whatever is over here by the x, and you've used completing the square. Will it be the same answer as when you use the quadratic? Yep, right on the money. In fact, reminder, we in class, we spent some time taking the general quadratic and developing it using this technique of completing the square. And I told you that, I don't know about on this test, but that's something all of you should be able to follow through on. With even though you don't know what A, B, and C are, you still should be able to follow these steps to come up with. Difference quotient. So here's an example of a question. You're given a function, and you're told find the difference quotient. So that means you want to find this thing in red out here on the right. You want to find that. In order to find this, you have to know what f of x plus h is. So that's really your first order of business, finding f of x plus h. So in this case, it's a lot of horsing around because you have to plug in x plus h wherever there's an x, so in both places. And you got to do this x plus h cubed thing. And you got to hammer that out. There's no shortcut for that. You got to do x plus h times x plus h. And then you got to take that answer times x plus h again. Anyway, then subtract the x plus h that's on the back. Bring it all together. All right, now we've got this numerator of this red thing done. Now you got to subtract the original function, which I did right here, and then put it over h, and you're in deep trouble until you can get that h on the bottom to cancel. We can, because there's an h in every one of these 4 terms. So you can factor it out. Now we've got the difference quotient. I don't know. Let's just I want to show you one more. Here's another one. Given the function f of x plus h f of x equals square root of x plus 1. And let's say the directions were, find difference quotient. Sorry, this thing is slurring here. I'm getting all kinds of slurring. But anyway, so you're given a function and you're told to find the difference quotient. So that means, again, you are looking for this. So that's what you're aiming for. And the first thing you got to find is this f of x plus h. So you plug in an x plus h where there's an x. Okay. That's not hard. But now you got to subtract that and divide by h. And there's no way in this first expression here, there is no way to get rid of the, I made some marks here. There's no way to get rid of that h, is there? Can't switch to my eraser. There we go. No, why is it not switching? There we go. So there's no way to get rid of this h. That's where so here conjugates turn out to be, remember, important because it got to get that h out from under this root, otherwise I can't cancel. So I multiply by the conjugate of the top. My apologies. So anyway, you get the difference of two squares. Finally, you can this h is out in the open and can be canceled. And at the end there we have our different, that's our difference quotient. All right. Just a reminder, the greatest integer function pops up periodically. Came up several of your questions regarding continuity. And don't forget 3 special limits we had that you really have to know by heart. There they are. The limit as x approaches 0 of the sine of x over x is 1. Secondly, the limit as x approaches 0 of 1 minus cosine x over x is 0. And then we've got our special e limit. So as far as what kind of things you may not have thought of, that covers that. So now, now we're starting to look at the exercises in the review at the back of chapter 1. There's 2 pages there. I think it was about 80 questions. Those would all be candidates for things I might ask about. That would be where I would look for questions. So I don't know if any of you have been there or not, but let me open it up to you now. Do you have any specific? So at the beginning of the class, somebody asked me questions about, what kinds of things can be on the test. I don't know if I've clarified that or not, but did you? I'm trying to remember exactly what was asked. So whoever asked that, do you feel like you have an answer to that now? Hello? Whoever that was that asked that question. All right, they're out to lunch. But okay, let's just take a look at this first. Here's a question from the review. What's this limit as x approaches 3? Well, you really can't find out until you factor that denominator. So here's a case of, oh my gosh, I got to know factoring. Yep, you do. So in this case, turns out the denominator was x minus 4 times x minus 3, and thankfully the x minus 3's cancel. Why? Because otherwise you would get a 0 on the bottom and you would be stumped. Because that cancels, you get 1 over x minus 4. And you plug in a 3, it's 1 over negative 1. Oh, the limit is negative 1. Let's jump ahead. Let's take a look at number 17. So here we're given a limit as x approaches -2. We can't substitute. But we can factor. That denominator is the difference of two squares, t plus 2, t minus 2. We can at least cancel the x plus 2's. Now can we plug in? Yeah. -2 minus 2 is -4. So you get 1 over -4, which is -1/4. Let's jump ahead. 23. Okay, here we go with trig again. What's the limit as x approaches 0 of 1 minus cosine x over sine? The answer is, I don't know, because you can't substitute, right? Because if you plug in a 0, what's the sine of 0? 0. And so we're stuck. This is almost like a conjugate problem. So look what I did. I multiplied by the conjugate of the top. Even though it's not under a root sign, conjugates turned out to be the answer. This gets a little bit messy, but when you multiply that, on top you get 1 minus cosine squared. On the bottom you get sine times 1 plus cosine. Okay, well 1 minus cosine squared is an identity for sine squared. Hopefully you remember this from trigonometry. Sorry. I'm having a slurry pen problem here. Can't seem to get my eraser to work. So anyway, let me try writing this. This is going to be crude because I'm writing with my mouse. So sine squared of x plus cosine squared of x equals 1. And so if you can see, if I subtract cosine squared from both sides, what's that equal to? Sine squared equals 1 minus cosine squared. So that's where I got this from. In place of 1 cosine squared, I got sine squared. See that? Why? Did that do me any good? Yes, because now I can cancel the sine x that was causing all the grief in the bottom. And that gives me this expression down here. Now I can go ahead and substitute in. What's the sine of 0? 0. What's the cosine of 0? 1. And 1 plus 1 is 2. This is legitimate. I mean, that's the limit. So here's a case where the conjugate really helped me to solve this trig problem too. That's good that we saw that. Okay, let me get rid of that. All right. Let's go to another group here. How about we do in the review from, this is the 29 to 32 section. So this is good territory because this is about the limit laws. And the limit laws are super user friendly. So here we got to do the limit of the product of two functions. Well, you can find the limit separately and just multiply. And they gave you the limit separately. The limit of f of x as x approaches c is -6. The limit of g of x as x approaches c is 1/2. So what's the limit of the product of the two? -6 times 1/2, which is -3. And what's the limit of the quotient of the two? The quotient of the two individual limits. So this is, let's take a look at 31. What's the limit of f of x plus 2 times the limit of g of x? What's the limit of g of x? They gave it to us up here. What's 2 times that? 1. What's -6 plus 1? -5. It's just literally, it's like this turns out exactly like you'd hope it would. So I'm guessing you won't have too much trouble with that section. So here it says in 39 to 48, this is just the beginning part of that, find the limit if it exists. So 39, no problem. Substitute, you got your answer. What's going to happen with that? Let's take a look at 41. How do you find that limit? I can't substitute. That won't work. Oh, I got to use the conjugate because of that root. So I multiply top and bottom by the conjugate of the top. On top, that gives me x minus 4. Praise the Lord. X minus 4 is going to cancel with that x minus 4 on the bottom. That's going to eliminate the reason I couldn't substitute. So you have left 1 over the square root of x plus 2. Can I substitute now? You bet. Square root of 4 is 2. 2 plus 2 is 4. Limit 1/4. Let's go back and take a look at 42. That looks an awful lot like one somebody asked me about in class yesterday. So 3, what's the limit of that thing as x approaches 3 from the left? Okay, so that means approaching 3 from the left. So like 2.99 is just to the left of 3. And when you take 2.9 and subtract the 3, of course, you get a small negative, right? And on the bottom, when you take 2.9 and subtract 3, you're going to get a tiny on top, we're going to get a negative, but the absolute value will make it positive. On the bottom, you're going to get a negative, and it stays negative. And what's a positive divided by a negative of the same value? You know, something divided by itself is 1. 1's positive, 1's negative. I think we did one just like that in class the other day. Next section. Find the x values at which f is not continuous. And then tell me which of those discontinuities are removable. Remember what removable means? Basically a hole, right? If it's a hole, you can plug it, and it's called a removable discontinuity. Well, 49, there's no discontinuity there. Likewise with 50, right? What's going to cause a problem there? Nothing. But when you get down to 53, okay, well, is there a possibility that denominator could be 0? Let's factor it and find out. You factor it and you get what I wrote here, x times the quantity x squared minus 1. Can either one of those? So x could be 0. That's 1. And in this one, x could be 1 or negative 1. Now, which is which? Why did I write that when x is 0, that's removable? I would like an audible answer to that, please, from somebody. Why did I write? Yes, go ahead.
When x is 0, that point cancels out on the graph and it makes a hole.
Yeah, the cancellation occurs in the algebra here, and you're right, that makes it a hole. Thank you. And why isn't 1 and negative 1 removable? Well,
nothing cancels them out.
Yeah, thank you. Very good. All right. Let's go to the next section. Here's another section of directions in the review exercises. Describe the intervals at which the function is continuous. So now you're trying to make an interval. Okay? So 57, is there anything that makes that discontinuous? No. So we would write this right up on top here in blue. Wouldn't that be the interval from negative infinity to infinity? In other words, everything, it will be continuous forever. Now 58, that's not true. You can see that negative 2 is going to cause a problem. Now we could factor the numerator and see if x plus 2 cancels. I can tell you right now it's not going to. So then I know negative 2 is out. So you could say from negative infinity up to negative 2 continuous, and from negative 2 all the way to positive infinity, it's continuous. It's just not continuous at that one point of -2. 59, square root of x minus 4. When is that not going to be continuous? What can't you calculate? Well, if x was what? Anything smaller than 4, we would have a problem. 3 would create a negative, and we can't take the square root of a negative. So from 4 on up, we're okay. Square bracket at 4. Why square? Because it includes 4. You can take the square root of 0. And then, of course, forever. Tell me about 60. You guys recognize that notation? What is that around the x plus 3? That's that greatest integer symbol. And how does the greatest integer function look? Isn't it that step function? So every time the step hops up to the next step, it's discontinuous. So this is going to be discontinuous in a lot of places, right? So, I mean, anytime x is a whole number, an integer, like 4 plus 3 is 7, and the greatest integer of 7 is 7. Right before that, it's down a step. So like take 3.9. What's 3.9 plus 3? 6.9. What's the greatest integer of 6.9? 6. So it's down there at 6, and as soon as it goes to 4, hops up. So it's discontinuous every time x is a whole number. Yeah, here again in 61 we have one of those. You see that we have 2e to the greatest integer of x divided by 4 power. Okay, so again, the greatest integer of x. So when x is, let's say, 3.9, what's the greatest integer of 3.9? 3, and the exponent will be 3 over 4, 3/4. But as soon as it goes to 4, the greatest integer of 4 is 4 and 4. So that you've got this hopping every time x is an integer. So one way to say that is from the, at any integer is, this is saying from k. So it's continuous for a whole step. So from k all the way up to k plus 1, and then it hops up. Then from that one, so it's got these lengths of 1 that are continuous. But every time it gets to the integer, it hops up. 62, do you agree with that one? Where did I come up with that one? Well, what happens when x is 5? 5 minus 5 is 0. The absolute value of 0 is 0. And what's the natural log of 0? It can't be done because they're asking e to what power equals 0. And no power will ever make e equal to 0. And then, of course, -2 times 95. So basically, x can't be 5. And isn't that what I'm saying here in my intervals of continuity? It can work any number less than 5, any number 5 or bigger. We're okay. But it can't be 5 itself. Find vertical asymptotes. 69 is easy, right? 0. 70. That's easy. 2, right? 71. Actually, that's pretty easy too, because what's the factorization of number 71's denominator? Anybody? Number 71. What happens when you factor that denominator?
Is it x plus and minus 3?
X plus 3, x minus 3. Yep. And so does that tell you anything about the asymptotes?
Would there be 1 at 3 and negative 3?
Yes, it does. Excuse me. How about 74? There's a trig question again. Vertical asymptotes. Cosecant. Oh my. What's cosecant the reciprocal of?
Sine.
Yes. And when is the sine 0? When is the sine 0? At 0 degrees, at 180, and every time you hit the x-axis, the sine is that, remember, that vertical coordinate, so that would be 0. So when that's 0, I can't take it to reciprocal. So when is that true? At no pi, at 1 pi, at 2 pi. So when at x could be any integer, if x is any, whole number like 1, 2, 3, ... that thing has a vertical asymptote. How about 75? What can you not take the natural log of? You can't take the natural log of 0. Because there is there's no power you can come up with to put on e that'll ever come out to a 0. All right, now when in 75 will that be the natural log of 0? When x is either 5 or negative 5. Yeah. All right, well, this is really no different. How are you going to do 77? Well,
would you factor out the top and try to see if it cancels with the bottom?
I would try that, but that's not going to work because the top is x plus 1 times x plus 1. But you're right. I would look at that. So let's think it through this way. It says x is approaching 1 from the left. Okay? So what happens as x gets closer to 1, but it's a little bit less? Well, on top, something really close to 1 squared is going to be 1. Let me, my pen's not working real great, but let's try writing this down. Okay, so here, this is going to approach 1 squared, or 1. This is going to approach 2, because 2 times, 0.99999 is going to be really close to that. And this is going to be a 1. So on top, we're going to get a 4. Okay, what's going to happen on the bottom when it's approaching 1 from the left? So it's like 0.9-ish. What's 0.9 minus 1? It's a negative and it's real small, right? So you can see I have it down here. A negative tiny. What's 4 divided by a negative real minute number? 4 divided by anything really tiny is going to be huge, and a positive divided by a negative is a negative. So that one turns out to have a limit of negative infinity. How about 78? As x gets closer to 1/2 from the right, well, on top, you're going to get 1/2, right? I don't know what this thing is, bonkers. So on top, you're going to get 1/2. And on the bottom, what's going to happen? As x approaches 1/2 from the right, so it's a little bit over a half. What's 2 times a little bit over a half? A little bit over 1. And what's a little bit over 1 minus 1? A tiny positive number. Sorry about the bad penmanship. And what happens when you divide 1/2 by a real tiny positive number? It's going to be infinity, and this time it's going to be positive infinity because it's positive divided by positive. So that kind of a limit might be asked about. So one more time, I'm going to go back. Go ahead. Somebody wants to talk.
On the 2.5 assignment, can we go over just like one of the finding a one-sided limit ones again?
Okay, back to 2.5. Sure, just a sec. Which one did you want to look at?
Any of the odd ones on finding a one-sided limit?
Yeah, what numbers schemes are those? From where?
37 through 51 odd.
Thank you. So let me get to that. 37 to 55. So starting with 37. All right. So let's take number 39. One-sided limit. What's the one-sided limit? What's the limit of, as x approaches 2 from the right, of x over x minus 2? Well, on top, you're going to get what? A 2. And on the bottom, you're going to get what? Something just a little bigger than 2 minus 2 is a real tiny positive. What's 2 over a tiny positive? You know, 2 divided by, what's 2 divided by 1/10? 20. What's 2 divided by 1/100th? 200. What's 2 divided by 1 over 1,000? 2,000. And see how it's just getting huger and huger and huger. And so infinity is the result. Let's do 41. So what's the limit of that as x approaches 3 from the left? I gotta get rid of this so we can look at the whole thing here. Okay. So as x approaches -3 from the left, well, can we factor that denominator? Yes. On the bottom, you see I get x plus 3, x minus 2 is another name for it. So here's my factorization right over here. What happens if I try plugging in a -3? I get a 0, so I can't use that. But notice the factorization allowed me to cancel the x plus 3's. So I get left 1 over x minus 2. Now can you substitute in a -3? Yep. -3 minus 2 is -5. 1 over -5, which is -1/5.
So back to 39 that we worked on, when you have like when you have the denominator like that. So like you would use like you use 2.01 and you put that for each of the x's.
Yep.
That's coming from the right.
Yep.
Okay.
And you get that 2.01 on the top, and what do you get on the bottom?
0.01.
Yeah, and if you carry that further, so you got this number divided by this thing that's getting smaller and smaller and smaller, and it's going to go to infinity. So we're down close to the end. Did anybody else want to bring up a question? So we've got another day of this coming tomorrow. You want to dig in and really, what would happen if I gave you one of those questions on that review? And I think if you're ready for that, you're probably ready for this test. As far as time, I'll just make another comment on the length of the test. You've heard me say that I will guarantee that if you need more time, I'm going to give it to you. So if I'm going to make that claim, I really am not real thrilled about if everybody in the class wanted more time, I would go crazy for the rest of the day. So guess what? I really do aim for the test to be real reachable. So I'm going to guess most people in the class shouldn't have trouble getting done on time. That doesn't mean, if you do, that's fine. I'm not criticizing you in any way. I'm just saying the test is aimed at being kind of on the safe side. So, maybe 40 minutes worth, and then you still got 10 minutes to look it over, check a couple problems. But again, it might take you longer. That's perfectly okay. That's why I gave the guarantee. All right, well, we've gone to the end of the class. Thank you very much. Good questions. See you tomorrow.